So in a structure of compiler, we have to see the details of all the stages which comes in the process of compilation. Okay. Before that, let me tell you, we are following the book Aho Allman, and I believe you would have seen this book till now. You would be studying this book. So we are going to see the structure of compiler. Basically, for compilation, what happens, you can broadly classify these two into two phases. Let me call them analysis phase and synthesis phase. Okay, let me call them analysis phase and let me call them synthesis phase. What are these phases? In the analysis phase, what we are going to see, we will get the source code here. Now this source code will be like streams of character, right? Character after character, character after character. Definitely there will be some semicolon, there would be certain blank spaces, there would be certain carriage return, enter, or whatever these things. But all of these can be considered as a stream of characters. Okay. So now from this stream of character, what you have to do is you will find out the meaningful statements, right? So finding this, in the process of finding this meaningful statements, you have a certain programming and you have done something, you can recognize that whenever semicolon is there, enter is there, you can recognize that it is a one line, and then again you can process one statement to find out the variables used, the symbols that have been used, and different other things that have been used in this particular statement, so that later on you will try to find out the meaning of these symbols and operations that have been used in this statement. Okay. So what we did in this analysis phase, you started with the source code, you tried to find out one statement. For each statement, you try to find out the meaningful portions. Let me call them tokens, or you can also call them lexemes. We can call this phase as lexical analysis phase. Okay, let me write it. Here you will have lexical analysis. Okay. After lexical analysis, what actually happens? You have streams of tokens. Okay, let me say it as token streams. Okay. These token streams are passed to next phase. You can call it as syntax analyzer. So in this phase, syntax analysis, what will happen? For this tokens that you have produced here, you will try to find out whether the syntax is correct or not. In this process, you will perform parsing. You would have heard this word, that you try to parse a particular statement whether it is correct or not. In this process of parsing, you used to create one parse tree. Later on, we will see when we will go in detail on syntax analysis, we will see that how these parse trees are created. and that may be the main portion of your compilation, compiler design subject. So these parse trees you will create, and this parse tree will be passed to next phase. Let me call them semantic analysis. Semantic analysis. Now, what happens in this semantic analysis? The meaning, semantic means meaning. So the meaning is checked here. According to the parse tree here verifies certain things. I will give you an example according to the book. We will see how it works. So you get a parse tree here. Then this parse tree is checked semantically whether the meaning of this statement is acceptable or not. Also meaning like the variables that have been defined, whether the type checking whatever is done, these all the things are done in semantic analysis. That definitely syntax is correct, but is it possible to have a float variable for indexing an array? Okay, certain kind of type checkings which is important for the program to execute correctly, those meaningful analysis is done in this phase, semantic analysis phase. Those who pass this semantic analysis, you will get a parse tree here. This parse tree is given to a next phase. You can call this phase as intermediate code generation. Okay, this analysis phase is not here. After this intermediate code generation, when you will get an intermediate code, after that this synthesis phase will start. For now, in this intermediate code generation, what will happen? This is not the final code to be generated by the compiler. It is an intermediate representation. Generally, you will see when you will see this intermediate code representation, we will see 3-4 different kind of representations possible. One of the popular representation that you will find will be 3 address representation. For now, let me write you get intermediate representation. Okay. You get an intermediate representation. So now, this was the whole phase of analysis. Okay. Once you get an intermediate representation for your source code, then your synthesis phase starts. Let me write this synthesis phase here. Okay. So after this synthesis phase will start. Okay. In this synthesis phase, what will happen? the intermediate code or intermediate representation that you have, it will be improved. Okay. Why? How it will be improved? Definitely in this phase you will have the optimization process. Okay. Here you have an intermediate representation. Now what can you do? You can have a machine dependent code optimization. Okay. So this intermediate code that you are getting after analysis phase, some optimization is done. Means certain statement which was not that useful. Suppose you have 100 statements and you can improve it by reducing some of the statements. Then this kind of optimization can be done. Suppose you have kept one extra variable for storing some constant, then those variables can be replaced by the constant itself. Such kind of optimization can be done here in machine dependent code optimization. So after optimization also you will get this same intermediate representation, just it is optimized, right? So let me draw it like this, and then I will write here the same thing, intermediate representation, but it is optimized. Intermediate representation. Okay. So after this optimization, what you have to do? You have to generate the target code. That is the only thing remaining now. So you will have a code generation process. Okay. After this code generation, you will get a target code. Okay. So this is the process. I should say this is whole compilation process. Okay. For certain compilers, what can be done? This target code itself can also be later on optimized. Okay. It's okay. Let me. So a target code can itself be optimized in certain processes. Here one more phase can be there. You can have machine dependent optimization. The same thing I can write code optimization. This was the intermediate code which was optimized, and this is the target code finally which is being optimized, and after that you will also get the same target code. Okay. So this portion will be considered as synthesis, and this portion will be considered as analysis. During all this process, one thing that can be used will be symbol table. Okay, you will have a symbol table which will be used in lexical analysis phase, where you will store certain information in all other phases as well. This symbol table will be used. These all the phases will also be interacting with error handler. Okay. The errors are something you can find in any phase, so those can also be reported. So this was the, let me make it small, this was the whole process of compilation. Let me also say that this can be considered as a structure of compiler, where for the source code you started with lexical analysis, where you form the tokens. Let us have an example actually, which will make it more clear. According to the book, what happens in lexical analysis phase, you store some, given the code, let me start with the code. In the example here in the book, as you will see, in the book the example is suppose one variable position is equal to initial plus rate into suppose 60. So let me write it in a small variable name. P is equal to I plus R into 60. No problem. Now let us have a semicolon also if you want. Okay, if you want semicolon, if you don't want semicolon, it is your wish. Now in lexical analysis phase, what will happen? In lexical analysis phase, actually we read a statement. Suppose this is the statement. So for this statement, you will try to recognize the variables, different identifiers, I should say, identifiers along with the constants and the symbols which have been used. Okay, these all will be considered as different tokens, and you will store this information in symbol table. How will you store? Suppose this is your input, this is your statement, then you will have to store it as, let me write here, you will write it as token name, comma, the attribute values. Attribute values. So for this given example, this is one identifier, so this will be one token. So you will store P, comma, it is at the first position in your symbol table. Okay, so this is 1. Okay, now this is equal to. So equal to, what you will do with this equal to, whether it will be a token or not. Definitely equal to will be a token. However, since it is a assignment operation, it has already known symbol, so it will not need extra attributes. So you have one token as equal to. Will this I is an identifier or not? I is also an identifier. So this identifier I will also be considered as an identifier. Let me repeat here again. P is a variable. So while writing in the symbol table, we are not writing the variable itself. Okay, we will write some kind of name for it. Like if this thing is an identifier, we have defined in our grammar or these kind of things. So let me call, we have defined identifiers as ID. Then in place of P, in place of name P, you will write ID. Similarly, I is also an identifier, R is also an identifier. You will write here ID, comma 2. Okay, this is the second entry in your symbol table, I should say. Then you get a plus symbol. Plus symbol can also be considered as a token. However, it is a known token, so it is a plus symbol. Then next you have R. R is an identifier. So this is the identifier. You will have to give it an entry in a symbol table. So ID comma third entry, suppose. Okay. Then the next thing is this symbol. This is another symbol which has a meaning, no problem. After that you will have the 60 constant itself. So whether the 60 will be identifier or not, definitely it will be identifier. You can write the 60 as like this, or certain times you can define in your grammar. In that case you will have to write its definition. If at all for 60 you have defined as number or constant, so you will write constant comma 4. This is fourth entry in symbol table. Okay, if you are writing it directly like this, compiler is able to recognize, then it is okay. You can write like this. If it is semicolon also, then for semicolon you will also have a token. Okay, maybe the meaning of this has already been defined, so you need not give an entry in symbol table, that kind of thing. So for this particular statement, how many tokens you have? You have 1, 2, 3, 4, 5, 6, 7 and semicolon 8. So for this statement you have 8 tokens. Okay. So the job of your lexical analysis phase was this thing. Given the statement, break it down into all the possible tokens. Okay, and those tokens with the identifiers or these kind of things, they will have an entry in the symbol table. If something else to be done, means nothing else can be done. Okay, let me repeat. Given the statement, you have to tokenize it and write the possible entries in the symbol table. So now what is the next step? Next step was your syntax analysis, right? You have all these tokens. So in syntax analysis, what will happen? You will create a syntax tree. Okay, I have written it as a parse tree, but no problem. It can be called as a parse tree or a syntax tree, no problem. You will have a certain kind of tree, let me say. Hello? So in a tree structure, you will define what you will define. You will define whether whatever it has been written in a line, it is syntactically correct or not. Suppose you have, for this purpose you will have certain set of grammars, set of rules will be defined. Let me call them grammars. Okay, these rules will guide you to find whether the syntax written is correct or not. Suppose this multiplication symbol has higher weightage, okay, than the plus symbol, which means normally, as we have also studied, that the multiplication should be done before the addition. So what actually should be done while processing is r should be multiplied with 60 and then later on I should be added. Okay. So what you will do is you will try to find a certain organization of these tokens, so that you will easily define the precedence of these operations, and later on you can find whether it is correct or not. So a possible syntax tree, let me tell you, you can understand it later also. So left side of equal to, what is there? You have id comma 1, right? id comma 1. On the right side, what you have? On the right side you have all these things, right? So let me start with the operator. Shall I keep this operator first or this operator first? Let me write this operator first. Then on the left of this it is id comma 2. On the right of it I am keeping multiplication. In the left of it is id comma 3, and in the right of it is either 60 or maybe constant comma 4, number comma 4, whatever you have defined. So such kind of definition, such kind of tree will enforce that multiplication should take before addition. Multiplication of id comma 3 and 60 should take first. Here we will get the result, and then this id comma 2 and this particular result are added, and whatever the addition result you get, then this particular addition result is stored in id comma 1. Okay. So this kind of tree structure, if you are able to create, you can enforce what operations are to be done before. For enforcing such thing, the grammar rules are there. Using these grammar rules, you can easily form such tree structures. Okay. So you will see the grammar, see the given statement, and try to form the tree, whether it satisfies all your conditions or not. If during this process you will get certain errors, you can give this information to the error handler, which will display the error to the user. So this is what we do in syntax analysis phase. Later on, what you do is semantic analysis. In semantic analysis, you try to find out the meaning of all these things, whether it is syntactically correct or not. You have, as you have kept the 60 here in place of 60, should it be 60 or integer or float, or these kind of information that you have to check. Maybe if you need to convert this 60 integer into float, that is also a possibility. You will do it in this phase, semantic analysis phase only. So after semantic analysis also, you will get the same tree, but it is semantically checked whether it is correct or not. Whatever needed, possible type conversions if needed, they are done here. And after that, particular this phase, you can generate intermediate code. Let me show an intermediate code here to you, 3 address code. Let me write the code starting from here. Okay, in the last line will be this operation, right? So starting from here, this 60, if you are trying to convert into a float, then you will write a temporary variable t1 is equal to into float what 60, right? Okay. Another temporary variable t2, which will have the multiplication of this id comma 3 and this temporary variable t1, right? So id 3 is multiplied by t1, you get it t2 here, right? Now you will multiply id 2 with t2 and store here in t3. Okay, so in t3 you have id 2 plus t2, right? Then what will happen? You have t3 here. This t3 should be assigned in this particular id 1, right? So let me write it as t3 is here, id 1 is equal to t3. Okay, this is a 3 address code which is generated as intermediate code representation. Okay, this 3 address code can be later on optimized. What kind of optimization here you can see? Can you tell me some kind of optimization? Some possible optimizations. As I can see, some optimizations are possible. This particular into float, this function for this particular thing, in place of using this function all the times, what you can do, this is a constant 60. If at all it would have been a variable, then there is no option, but since it is a constant, you can directly consider it as 60.0, which will be this thing, float. So in place of having this one statement, t1 is equal to something, you can directly write here 60.0, right? So let me write it as t2 is equal to id 3 into 60.0. So this is float now. Now the next thing that I can see here, t3 is something which is being stored in id 1, right? In place of writing these two statements, you can directly write id 1 is equal to id 2 plus t2. Okay. Okay. So this process is really nice, where you generate a 3 address code which may not be that much optimized, but later on you have a certain phase. You have a phase, separate phase for optimizing this particular code. Now this is an intermediate representation 3 address code, but actually you do not want this into a 3 address code, right? You want a code code in a particular language. Let me call it as you want it in assembly language. Then you will write it in assembly language. What it can be assembly language? You want to load id 3 in a particular register. Let me load it in you want to load this in a float format, so LDF for float in certain register. Let me have a register R2. Okay, you want to load id 3. You also need this 60, you want to multiply it and store in a temporary variable t2. Why t2? Okay, let it be. We can store the result into R2 itself. In R2 we have id 3. Now let me multiply float. So you want to multiply and store here. You want to multiply R2 with suppose 60, right? 60.0. Since this is constant, you keep a hash symbol here to show that it is a constant. You multiply these two and store final result into R2 only, no problem. Okay. Now you have done this statement. The next statement is this. Okay, in R2 you have this particular information. This is id 2. You want to load it somewhere, and then you have to store here. Okay, so let me load I2 now. Okay, and this is also float operation. You want to load id 2. Let me load it in R1. id 2 is loaded into R1, and then what you want to do? You want to perform addition, right? So your addition will be add float operation, add store here. You have to add R1 comma R2, right? In R2 you have the result of multiplication, this first statement, right? Now you are performing the addition of R1 and R2. You can store the result in R1 itself. The real this thing assembly language code may differ a little, but still. Now you have result in R1. Now you want to store this result where? In id1, right? So you want to store floating point operation, it is. You want to store it in id1. What you want to store? This R1. So this is your final code that you wanted to write. Later on, if you want to have extra step to optimize this assembly code also, it may be possible, but the job of compiler, you can say it is over here, where it created. You started with lexical analysis. You tried to find out the tokens. These tokens were kept in symbol table. Later on, symbol table was used, grammar was used, and this particular parse tree or syntax tree was generated. Later on, this tree was checked with meaning, whether these meanings are correct or not. And after that, 3 address code was generated, intermediate code was generated, intermediate code was optimized, and then target code was generated. This is the whole process of compilation. You can say this is the structure of a compiler, where you are calling compiler is a software. So these can be considered as separate modules of your compilation process. These modules, whenever you will give the input, there will be a top module which will send your input to lexical analysis module. Whatever the output comes, and this output will be sent to syntax analysis module. Some output will come, and later on, in this way, this whole modules, the outputs are sent, and the final output can be received finally, which can be given as output of compilation process. So this was something that we have studied till now. Do you have any question?
Hello, sir.
Sir,
what is machine dependent code?
Machine dependent code means, say, whenever you write a code, it may be written on one machine, and this machine may have different hardware, different operating system. Because of that, your code that is to be run on this particular computer, the machine code may be different for different machines. Okay, not only the machines, let me also consider it as the hardware. When you are talking about hardware, there will be your processor along with the registers. How many registers your processor has, how many bit address code it allows. These kind of informations are also needed for the compiler to generate machine optimized code. Okay, so you would have heard that there was initially a certain processor, 8086 you can call them, where you have just 16-bit address line, or maybe the registers of 16 bits only, and maybe limited 8 or 16 registers only. But nowadays you may have 32 or 64 bit registers and so many number of registers. Accordingly, there will be dependencies on this particular hardwares. So whenever these things that you are talking about, when something you want to do which is machine dependent, this is done in the synthesis phase. Those things which are normally not dependent on machine, that are the part of analysis phase. Also, this analysis phase is also called front end. Okay, and the synthesis phase is also called as back end, because of this particular reason only, that it has not to do any with the machine dependency. However, this phase is little machine dependent. Okay, machine dependent means hardware dependent, basically I should say. Okay, now is it clear?
Yes, sir.
Okay.
Sir, according to the book, it was written machine independent code optimization
Okay.
after the intermediate code generation.
Okay. That would be better actually. That would be better, huh? Actually, this phase where you are doing machine, let me write it again. This is machine independent code optimization here, and later on again after target code generation you can have machine dependent code optimization.
Yes, sir.
So let me correct it again. You all can understand here that this is machine independent code optimization, where the code you have written is optimized. However, it is a general optimization. It is not related to the particular hardware. Here, but one thing is also correct, that the intermediate representation where it is optimized. However, later on you will get the target code which will be optimized based on your hardware that you have. Now, any other question? Anything else that you want to ask? Till now we have seen this particular things in compilation process. Then now what you have to do is you should go through the book, read these things from the book also, and later on then we will see some more things. I think although we have seen what symbol table does, but still we will revise a little these phases and the process of what symbol table, how it is managed, and those kind of thing, and then we can move further for other informations. Okay, so for now I think we have done enough today. And the next class is tomorrow itself at 1 o'clock. So let us meet again tomorrow. Till then, thank you. Aniket.
Sir, if we yes sir, if we can reschedule the tomorrow's class, because there is a workshop organized by the placement cell tomorrow at 11 o'clock. So if we can reschedule it in the second half.
So what is the possible rescheduled time when you don't have
So
any other class?
So from we can start from maybe 1:30 because that meeting is from 11 to 1.
Any other possibility?
mm, sir, at 2 o'clock we are also free.
All of you are free at 2 o'clock?
No sir, sorry 2.
But
Sir, sorry.
around 2 to 5 there is lab, sir.
Exactly sir, 2 to 5 is lab. Actually I thought it's free, but no, it's labs.
We will be free after 5.
Yes sir.
Okay, no problem. Tomorrow we can leave the class. We will meet again on Friday at 10 o'clock.
Okay sir.
Yes, sir.
Friday 10 o'clock we will meet. Tomorrow we don't have class.
So today's attendance, sir.
Oh yeah. So some of you have participated in that particular what we call it essay competition also, or what? Not, no?
Yes, sir, I have participated.
What is your roll number?
Sir, 190101116.
116. Okay, I am marking your attendance. If you want, you can leave.
Me too, sir. Sir,
Roll number?
108, sir.
8. Okay, I am marking your attendance. If you want, you can leave.
Sir, 103.
103 also. Okay. So roll number 1.
Sir, 115.
Present, sir.
115.
Roll number 1.
115. You have participated in essay competition.
Yes, sir.
Okay.
Yes, sir.
Okay. I have marked your
Sir,
attendance.
108. Can I leave?
Yeah,
Sir,
leave.
108.
Leave.
Okay, thanks.
Roll number 1.
Present, sir.
2.
Present, sir.
3 is already present. 4.
Present, sir.
5.
Present, sir.
6.
Present, sir.
7. Okay. 8 is present. 9. 9 is absent. 10.
7 is present.
Okay, 7 is present. 10. 11.
Present, sir.
12.
Sir, 10 is present, sir. Actually, I have some network issues.
Oh, no problem. 10 is present. 12. 12. Okay. 13.
Present, sir.
14. 15. 15 is present. 16 is present. 17.
Present, sir.
18.
Yes, sir.
19.
Present, sir. Sir, 14 is also present, but he is not responding. Maybe he has some net issue.
Okay. So 14 can write something in comment box, I think, chat box. Okay, let him write. Till then, 20, 21, 22,
Present, sir.
23.
Present, sir.
Okay. So roll number 14 has not written anything. I believe. Aman.
14 present, sir. Yes, sir. I got
Okay.
disconnected.
Okay, 14 is present.
107.
007 is already present. Very good. So the roll number which are absent, let me tell you. Roll number 9, 12, 20 and 21. Rest are present. Okay.
Thank you, sir.
Thank you.
Sir, Vikas Boro, sir.
Oh yeah, Vikas Boro. 1803, right? Vikas.
Yes, sir.
Vikas is present. Any other student? 1828 also.
Yes, sir.
So 1828 is not present today, right? Okay. Okay then. So, thank you. बाबूजी का दलाल समझ लिया हुआ है।